Hi, and welcome to the Kotlin Multiplatform Mobile webinar series. As you know, Kotlin Multiplatform Mobile went beta a few times ago, and that means that now it's a great time to start learning and adopting it. And one of the best way to do it, to learn this new amazing, of course, technology, is to visit our webinar series. So we had our first webinar getting started with Kotlin Multiplatform Mobile last week, and let's do a little warm-up. We will run a short survey in YouTube, in the comment section. So please, folks, tell me, have you visited our first webinar? And if no, put it in your task tracker, in your task list to watch it later. What we are going to do today? Today, we're going to discuss the hot topic. If I'm not mistaken, it was like one of the most popular questions during our first webinar. We're going to discuss how to make your Android application work on iOS. And we have our absolutely amazing speakers. By the way, folks, Kevin and Russell, they helped us a lot during the first webinar. They answered a lot of questions. And today, they will definitely share more information because Kevin and Russell are our today's speakers. So Kevin, Russell, hi, I'm happy to see you here because when you're on stage, that means that we will definitely be able to cover all the questions and maybe even more. Please introduce yourself and could you tell us what we're going to do today?
Okay, Russell, want to
go? Sure, yeah. My name is Russell. I'm a multi-platform developer at TouchLab. Been doing Kotlin multi-platform since pretty close to day one, and always get really excited about it. So excited to chat some today.
I'm Kevin Galligan. I'm technical partner at TouchLab. I've been also kind of doing KMP since day one, or even before.
Yeah. Kevin, we're going to discuss memory model today.
What memory model? What are you talking about? That's over. Those days are gone.
Good one.
I actually have one slide on it just so I can move right past it.
Okay. Yeah, move to 172. If you see incorrect dereference exception, you're on the wrong version of Kotlin. That's like the short version of yeah. Okay, sorry. What are we doing today? We're going to talk. Well, I'm going to talk about the title when I get into my context intro, because I wouldn't say you're going to quite make your Android app work on iOS, but we're going to make some Android-focused code work across different platforms. But let's get back to that later. That's the intro, I think. So, sorry. Okay, you go. I have a habit of derailing things, so don't try too hard to stay on topic. But we'll see how it goes.
Okay, perfect. By the way, while you were telling that we are not going to make our Android application work on iOS, I'm joking. So I checked the results of this small survey about the attendance of our first webinar. And looks like I did the bad marketing for it because 42% maybe they were joking and they like catch the vibe, but folks answered that which webinar? Folks, don't worry. I will post the link to the webinar in chat, and also in the description of this video, you can find the link to the blog post with description which beta, which KMM, and like what's going on. And also it contains the webinar schedule, so you can register for the future webinars and check the links of the past webinars. So don't worry, I will provide you all the needed links. And let's spend a few more minutes also to wait for more people to come. And I have the other question. Let's check again. Will we have any difference? I want to know, all our users, our listeners and viewers, what is your background? Like, are you iOS developer or Android developer, or maybe you do both? Or maybe you're experienced Kotlin Multiplatform Mobile developer. In that case, please don't hesitate, and also share all your opinions, all your expertise, and to answer all the questions in chat, because it turned out that our audience is really active, and during the past webinar, I was unable to answer all the questions, and only thanks to Kevin and Russell, we covered I hope half of them. So yeah, please type in chat and answer this small survey. Give me a second, I will check the results. Now I see almost 10% of iOS developers are watching us. Interesting. We have more compared to the previous webinar, but it's quite expected, as we want to make Android application work on iOS, and maybe iOS developers want to decrease the amount of work they usually do and learn how to not write the iOS code and just use the work from the Android teammates. Okay, cool. Okay, I think it's enough for warm-up, and now I have something to do to share the links with our viewers. And Kevin, Russell, your turn, and let's rock.
All right. So yeah, it's kind of a big topic. So we were preparing this, and we're like, we don't know where to start. So where we're going to start with is the overriding message is kind of everybody comes to this differently. Different teams, different types of apps. What you want to do with it. Even like you said, 10%-ish are iOS devs, and kind of what they're looking for. I would say. I want to quote Jesse Wilson here, not the least of which because I had to cancel a meeting just to have with him today, but to do this. But what his goal is to make the Android devs and the iOS devs mobile devs, and to give the iOS folks superpowers, being able to contribute back into the Android side and not just the other way. So it's really good to try to reach out to the iOS folks who I think all native mobile devs are skeptical of anything that has anywhere near cross-platform. And if you're not, you probably should be. I don't tell people that everything's perfect. So it's important to learn how best to approach things, and that's why we're here. So yeah, the context, it really depends on are you making a new app, which you're going to do both platforms at once and try to maximize your shared code? Do you have existing apps that you want to add some code to? Do you have do you have a new team? It's mostly maybe Android devs. Do you have existing teams that are Android, mixing Android to iOS? Everyone kind of comes at this differently, right? So, and that's a lot of what we're going to talk about today. The Kotlin tooling, is designed that you build the Kotlin and you integrate it with your iOS app. I mean, integrating with the Android app, it's all kind of Gradle, and not that it's easy, but it's kind of things that people are used to. The iOS side is sort of a different story. So, yeah, we're essentially going to talk about our experience working with different teams and kind of how different folks go about things. So, and about the title, I'm sorry, I got notes over here. I'm scrolling. It's I would say there's not a lot of taking an Android app and starting from scratch and making it 100% work in iOS. Although, if you want to see Compose UI in iOS, go check out the DroidCon London app. DroidCon London is happening in a couple of days, but it's shipping on iOS with Compose UI. That's quite literally taking your Android app and making it work on iOS. But we're going to be a little more nuanced than that. So speaking of the folks coming at KMM with a brand new app or Greenfield, Russell's going to kind of walk us through some thoughts there.
If we can throw up my slides. Thanks. So yeah, we're our focus today is this kind of scenario where you have an Android app or you have existing Android code and logic that you want to move over to the iOS side. But to kind of set the stage, it helps to kind of present the Greenfield case as well as a point of comparison. So, and the reason that's important is because most of the kind of Hello World apps and sample apps that you encounter in the wild are like sort of make the assumption that they're making an implicit assumption that they're living in a greenfield kind of world. Like they tend to be monorepos. They tend to kind of have the Kotlin build integrated into the Xcode build, which tends to not be the case kind of in a like pre-existing app. If you have kind of two existing production Android and iOS apps, you're generally not coming at things in the way that a lot of samples are. And I don't say any of that about existing samples to throw shade or anything, because like our can't-get sample is the same way. But yeah, so we'll talk a little bit about just what it looks like when you're doing KMP from the ground up. So yeah, your typical KMP sample, I'm repeating myself a little bit, sorry. Yeah, like tends to be in a monorepo, specifically because it means that Xcode knows where to find the Kotlin, and you can kind of integrate the Kotlin build step into the Xcode build in a simpler way. It tends to kind of focus on maximizing shared code, because when you're kind of starting from scratch, it's a lot easier to do that. And it tends to assume it makes a lot of assumptions as if you're coming at it as an Android developer, because a lot of people kind of first starting out in Kotlin Multiplatform are. So yeah, it assumes that you kind of have a typical kind of JDK setup installed and stuff, and a lot of that is not necessarily true of your typical iOS developer. And so when you're kind of starting to try to integrate this kind of stuff in an existing production environment, you can run into some friction points there. So we've kind of started to think about these sorts of samples as more kind of a demo than like a realistic scenario for an existing production team that might be trying to adopt this stuff today. But the Greenfield app can still be like a really nice model for a production team that's starting up a new app, which is a thing that happens sometimes. So like we've talked to companies and stuff who kind of did their first KMP pilot as like a second app that was either like for internal use or like a secondary kind of thing to their main app. And that's where the kind of greenfield scenario can be a good model. So when we're doing this sort of app at TouchLab, it tends to look a lot like CampKit. So CampKit is the sample app that we put out a couple of years ago that you may have heard of if you know us at TouchLab. It kind of shares code usually up through the view model layer, and then kind of wraps platform-specific UI around it. And that view model might be a small v or a capital V view model, kind of depending on your needs. We've kind of tend to lean towards using the Android architecture components view model when we're sharing view models. But there's a lot of kind of conversation around that in the Android community around whether that's still a useful thing to do or not. And it always has a little bit of kind of translation code at the language boundary, where as you're moving from Kotlin through Objective-C into Swift, you need to be a little bit careful about what the interface that you expose looks like, so that you create an API that's kind of pleasant to work with on the Swift side. So for a little bit more kind of detail on the view models, like we sometimes have like a little bit of a separation between like platform specific parts and common parts of the view model layer, where you might have like the Android app doing something slightly different than the iOS app that kind of only lives in like one control that works on one platform and not the other. But often you can share a lot of that view logic in a common thing. And when you need platform-specific, you do occasionally need platform-specific stuff lower down the stack as well. And usually you can achieve that via some sort of dependency injection solution, where you're injecting an implementation of whatever it is that you need. And I've had to do that numerous times working on various projects. So like had one a year or so ago where we were porting a bunch of kind of socket communication logic from an existing Android app and getting it to work on iOS. And so we could kind of pull a bunch of the higher level logic into shared code, but we still had to inject the kind of engine that the socket ran on in a platform specific way. Yeah, and that's the point that I just talked about. These sort of things, like the Greenfield app setup tends to work nicely, or like feel really nice right when you're starting out, but it gets less and less simple as you start to grow. So complications start to arise when, like, what happens when you can't implement the feature on both platforms at the same time because it's too big. You need multiple people to work on it. You need people with different expertise to work on it. What happens when you have a bunch of people kind of working on the iOS side, more on the Swift layer, but they're stuck kind of dealing with build times and stuff that are have improved remarkably from where they've been in the past. But it's still nice sometimes to be able to avoid the Kotlin native build if you can. And like as an app grows, you start needing to do more and more platform specific things. And so you need to start kind of thinking about things in a less kind of single code based way, or a less kind of like one bit of code runs everywhere kind of way. And what's great is Kotlin Multiplatform is incredibly flexible. And so it's easy to adapt to all of these sorts of things. But yeah, we're essentially talking about like what happens when you grow to the point where you start needing and using that flexibility. And then all these sorts of complications and more then to continue to come up as we talk about integrating shared code into pre-existing apps. So I'll pause for a sec if anyone has questions before passing this back to Kevin.
Yeah, I would like, as always, some questions are not directly related like to specific points, but they definitely like relate to the general topic. And we always have this question with the request to compare with other cross-platform solutions. And yes, it's we discussed it a lot, but I think it's a good idea to maybe repeat some points. And the thing that I enjoyed today, that now we even maybe don't need to answer them because the audience, our users, are already answered them. And I just want to first read some comments. Yeah, for example,
you want to talk about why not Flutter? Like,
yeah,
we could change the topic of the whole talk, and then we can just go into that.
No, like before integrating, before migrating, and blah blah blah, you need to like make a step back and answer why did I choose it. So, but we have some answers here. For example, not need to learn new language. Michael answered availability of developers, good one by the way. Or ability to use native whenever you need to, and like some other stuff. But maybe, folks, you want to add something here also in terms of our today focus for integrating with iOS.
I'm like, you're never going to talk to someone who's spent more time preparing for this question. I'll give you some answers. No, those are good answers. But, you know, it's not, you know, it is interesting. Like when we first started doing KMM, like did a blog post very early on, and someone pulled me aside and they're like, "Are you trying to kill Flutter?" And it's like, no, it's a different technology option. Why we don't, you know, focus on Flutter is, it is, you know, it's a different language, it's a different thing, but for us, it's really, we tend to work with, you know, I would say teams, existing apps, things like that. And one of the things that we talk to, if you're a startup and you're doing an MVP, you know, should Flutter be on your radar? Like, of course. I mean, it is you can write this thing, you're going to ship to 2 platforms. I mean, I would argue if Compose UI on iOS becomes more mature, then you have a real, like, they're very similar at an architectural level, except Kotlin also is designed from the ground up to interop with existing systems, and that is like the risk reducing aspect that the reason we do this versus that. You can add some Kotlin if you're, having some kind of trouble where the Bluetooth stack or the whatever is kind of a pain on a particular platform. It's very easy to just carve out, pass it an interface, do your platform specific stuff. There's very little risk. You can do that on Flutter, but being able to do something and being a part of the core design of the platform are two different things. Like, you don't have to do an IPC channel with Kotlin. You don't have to, do an overlay with a transparent view so you can get at regular views. It's just, Flutter is a portable UI system that I would say is great in its own world, and it doesn't interact very well with the native platform. React Native has some very similar issues, and Kotlin from the ground up, it's a harder problem to solve, the interrupt. It takes longer to solve it, but if you can solve it right, it's a less risky option, and especially when we're talking about, if you had asked me in 2014, where will we be with native mobile in 2018, I would say, oh, it's all going to be web. That's what everybody kind of thought, and that's not where it went. Native exists for a reason, and it's not just because there's old apps. It's because people want the best experience for the types of, like, if you're doing an internal enterprise app, like, it's a different story. If you're making an app you want people to use and like, native is the least risky. It's more work, and Kotlin's approach is to try to minimize the work of that, as opposed to making a big decision on a different platform. I could go on and on and on, but we don't have to do that. But that's the answer for why not Flutter. It's like sometimes Flutter, but it's not.
But I put this topic to our webinar backlog because we usually spend let's spend a few minutes to answer this question, but looks like we need a dedicated special webinar for it.
Yeah. Well, so the thing I would add to it, though, that to kind of tie it back into what we're talking about today is the place where Kotlin really shines is when you're integrating into pre-existing code. It can the Flutters and the React Natives are absolutely optimized to be your entire app, and they work best when you're kind of building that from the ground up. Right. And when you're comparing that in a kind of pre-existing app scenario rather than in a building a new thing scenario, I think Kotlin really shines.
Yeah, and one of the things I wanted to bring up, and we're kind of going in different orders, but Russell was talking about greenfield versus existing apps, and I would say one of the challenges. Okay, so if it sounds like, wow, we're talking about a lot of problems that are scaling problems, it's because Russell and I are talking to teams who are currently trying to scale. That's our lot. So that's a little bit of recency. If you're building an app by yourself, clearly go get the tutorial, start greenfield. That's straightforward. What we're talking to actually is teams that are they started with a module, and then their next app, multiple teams we talked to recently, hey, we're going to do this from KMM from the ground up, and then they face the problem of how do you do two platforms in parallel with some shared code and not break each other's code, and how do you add a feature here and when do you add it to the other platform? They're not unsolvable problems. It's just, again, everybody kind of does it different, and so if you're a team that's doing that, we'd love to hear from you and hear your approach, because it's kind of weird. Everyone's kind of got a different way of doing development. But one of the things,
branches. I'm joking.
Yeah. Yeah. No. I mean, if you're gonna do as an example, I don't want to go too deep into it because we'll be here all day. But if you're gonna do features, if you're gonna add features, feature dev, if you're gonna add a button and do a thing, and you want to keep it 100% in parallel, then it's all right. Sometimes in the Android side, they'll add the feature to the shared Kotlin code, and then they'll do a PR, just literally pass it off to the iOS side to implement the UI and the other parts that are going to be in there. That's how you keep that in lockstep. But sometimes you want to do one platform and get some user feedback until you solidify that feature and then add to the other platform. So it's how you orchestrate that is a little complicated. But what we've been focused on recently, just because we want to increase adoption, is just how to get teams started with a module. And then we kind of are releasing some stuff, and then now we're swinging back internally with some stuff that we're not quite ready to talk about yet, but we're improving the Swift interface and also thinking through all right, what if you're going to maximize things even further? Because Compose and Swift UI are both essentially state monitors and renderers. So what if you could make the state that comes out of the Kotlin on the Swift side look like you'd want it to look like for Swift UI? When we talk about why not Flutter, I'm not thinking about why not Flutter today, why not Flutter 6 months ago. It's why not Flutter 2 years from now? That's where my brain goes, because we're constantly working on this new stuff. So, I can make a case for why not Flutter today, but I'm why not Flutter in 2 years? going to be really interesting. But Flutter keeps working on stuff too, so we'll see how it goes.
Yeah.
All right. Anyway,
Yeah.
enough about the down the road.
I suggest to move forward.
Yep.
Folks who are listening to us, I see your great questions, some specific questions about modularization, for example, or using flows. I would suggest to keep these questions because I believe we're going to cover some like iOS API questions. But I see them, and I promise I won't forget about them. So please stay tuned. And folks, let's continue.
All right, I'll get into the the schedule part of this because we do have a demo, but we have to start the demo building because it takes a little while. Then we come back to it. So we'll plow on through. Yeah. So Greenfield is one way.
Yeah, we can drop the slides for a second too.
Okay, and then yeah, the other side of the coin is, and this is, you know, again, because who we're working with mostly is teams that have existing apps, existing native apps, and they want to approach adding some Kotlin to that. And again, like that's one of the superpowers of Kotlin and shared Kotlin. You know, and I would say it's interesting. Every team, like every existing team we've talked to, essentially has started with this approach. Rather than we've talked to a few that sort of started with like, okay, everyone install all the tooling and everything, and then there's a lot of pushback because you're adding risk into an existing build system. Right. It's not necessarily the build time, although it can be. It's certainly a problem. Not, but like Swift got build time problems too. But it is adding risk to a build system that is already quite complex. Any production system of any platform has a lot of complexity to it already. So adding something, especially that's experimental, is not necessarily going to get a good response. It has nothing to do with Kotlin specifically. It's just like nobody wants to add risk. So we've been working with a lot of folks about how to do that. And again, every team tends to start with like, we'll add a module and we'll add a couple modules and we'll see how it goes, and then work from there and have a gradual onboarding approach. So so there's multiple topics if you're going to do that with your team, right? And the topic, the first one is, it's a little simpler and a little more obvious. It's like, okay, what code are you going to try to add? And this, again, like every other thing I'm going to talk about, and pretty much everything in developer ecosystems in general, is like, it depends. Like, what is your app doing? You know, there's all kinds of team specific stuff, but there's general patterns that we tend to advise people, right? So the lowest hanging fruit is like, well, let's pick something that nobody really likes to do as a developer, right? And there's some really good examples there, like analytics. Analytics like has to be done very precisely. If you get the case wrong or the string's not 100% correct, like you'll get wrong results on the other end. But you as a developer don't necessarily see it until it's too late. There's not a lot of developer joy with analytics. There's no fun animation on the screen. It's something you don't see. So like nobody wants to do it. So what you can do, and when I say do analytics, you can add like a shared module with typed calls. So like one of the analytics is always like a string name with a bag of values map, right? You can add typed calls where you have to call a specific function with specific parameters, and that forces your code to do that correctly, and you can share that across platforms. It is often the first thing that teams try to do. You can do that in a limited way just to see how this works, right? I also say, you know, try some database and networking. I've in recent times met some iOS developers who don't hate core data, but for the most part, like throughout the iOS developer history, they haven't been into it. So you can write some database code shared, call into it, you know, and centralize your data storage and that kind of stuff. And networking is often a place where at least we'll start to do some calls because you have some proprietary logic around your networking. So take one module, add some networking into it. It's obviously KTOR, or, you know, generally speaking. And then there's also this category of stuff where it's like, it's absolutely critical that something needs to be correct, right? So my example there is like a tax calculation. You know, it's like you can't get it wrong, because if you get it wrong, it's a big problem. And in those contexts, you definitely don't want to write it twice. So it's a good place to start and at least experiment with a module, right? I also suggest sometimes to take an existing piece of code and that exists in both platforms and like put that into a module and share it. And the reason I say that is because you have an existing model. It very much lowers the risk of consolidating the code. However, that doesn't always appeal to people, because then they're just thinking like, well, now we're going to do extra work for things that already exist. So that one, again, depends on the team, depends on your tolerance. I would say that that's the least risky thing to do, but I've often had resistance to to people actually doing that, because they don't look at it like it's a cost savings. Anyway, so the next question is, after you figure out what you want to try to share, it is how. And again, going back to it, like, if you've got a small team, it's usually more palatable. If you've got a larger team, especially, and existing build systems, there is definitely resistance to say install the Kotlin tooling and put that all in there when you're at the experimental stage. It's like when you get to the next phase, it's a whole different story. So, and many teams have separate repos for their native apps. I mean, it's actually relatively rare that you'll have a mono repo, in my experience. I mean, obviously some places do. Again, every place is different. So if you have separate repos, structurally adding shared code becomes difficult. The hated word submodule is something we all try to avoid. So like, I don't suggest that even remotely until you're super there. So anyway, and again, mobile teams often aren't on the exact same schedule for development. Like one team might be out ahead of another at different times. So it kind of, all that stuff mixed together structurally, politically, you know, almost every team we've seen, they start again with publishing an SDK internally, an Xcode framework, and then the iOS team will consume that. And then over time, if people are, you know, as people get, you know, more, start adding more and more Kotlin, like you can do a little more integrated situation. But so that's, again, why we built this thing that we released a couple weeks ago. So I'm going to do a demo, and I'm going to minimize the screen so we don't get anything wrong. Okay, so let me know when I'm sharing.
Right now. Okay.
The point of this demo is to show you, like, we've talked to a bunch of teams. I talked to someone yesterday who's very much a KMM fan and added it to their app, like, and they said the same things that we've heard from everybody else, which is the Kotlin, everything about the Kotlin compiler and the tooling, it all works, and all the raw pieces are there, but you know, an Android developer doesn't necessarily understand how to publish an iOS framework, much less, you know, do it in a way that's going to be auth. You know, you're going to be able to handle the auth for your team, and like, do you go to Artifactory? Do you go to these things? Like, there's all these complications that then have to be figured out just to get started. So our goal here was like, let's take care of all those problems as best we can with a very simple Gradle integration library. Because these are not very hard concepts, but it's a lot to learn for the first time you want to do something. So we have this thing called KMM Bridge, or Cambridge if you're Russell, because he's from the Boston area.
I speak too fast.
And the idea is just that this is, you can, it's going to take your shared Kotlin module and just push it over into a publish, and then bridge these two repos essentially. Just, this is, you're getting started with Kotlin. You want to add a module to iOS, and you want to minimize the risk and make it as dead simple as possible, right? That's what KMM Bridge does. And this Kickstart works like this. Click use this template, and I'm going to name it whatever, KMM rules. And then I'll make it private, because most teams aren't going to have their code public. So that's the template. Let's let GitHub figure this out. When you're streaming, everything's slower. Okay, so you have to do one thing, which is go into the Gradle properties and change your group, because GitHub Packages does not like you using someone else's group. I've learned that out the hard way. So we'll do this. Just there we go. Okay, rules, and that's it. So we changed that group. Now, if you want to use CocoaPods, I'll show you that really quick. The only issue there is that you have to set up a separate pod spec repo. This is how CocoaPods distributes things. And then you have to do some SSH keys. If you pay attention to the instructions, it'll take you maybe 5-10 minutes. We're not going to do that here. We're just going to show SPM. So I just want to show that CocoaPods is commented out. If you want to add CocoaPods, you put that in there. So anyway, back to it. Just change the group name. Then we go to Actions. Click All Publish. Run Workflow. And then and then we let that build. So that's it for part 1 of the demo. So we can stop sharing my screen. We got to wait for this to, it'll take a while. Let me know when we're done sharing.
Yeah, we've done.
Okay, cool. Just going to pull back up my screen. So again, the whole point of the demo is like, if you want to share some KMM, you're gonna see how easy you can get started doing that, and we just have to wait for that to build. So there are some things that you kind of have to decide after that, like the KMM Kickstart is designed as a third repo. So your Android would include an AAR binary from that, and your iOS would include that. I would say it's generally easier once you decide you're going to do KMM to add a KMM module to your existing Android build, because it's easier to edit, it's easier to do stuff, and then you just publish iOS from that. Now, we talk to some teams, and that's a political issue, because then it just feels like another Android thing. And I mean, to some degree, it kind of unavoidably is, but your team has to decide how you want to do it. It's just easier, I think, to do the editing of the shared Kotlin within the Android context, just because you just hit play and the thing's done. But that's a decision you got to make. And again, like as I was talking about earlier, we were working with several teams to start with this model, and then now they're trying to do more and more feature dev together in Kotlin, and this model becomes something that you don't necessarily want to do. So you really do have to incorporate Android and iOS teams being able to edit and publish Kotlin like directly, because once you start doing a lot of coordinated feature dev, that becomes something that you're going to have to do. But again, this is where everyone kind of starts, so we'll see that. And that's that for that portion. We can do questions and then go back to Russell about libraries and ecosystem and all that.
Yeah, great. First, I need to admit that this question of how to distribute your KMM module to iOS part of application, it's like it's extremely viable part of all the ecosystem, and I need to admit that we are not yet covered it in our docs. So I think this is very important event, like on all our Kotlin Multiplatform Live. That's why our folks who are watching us, if you read the blog post with the announcement of Kotlin Multiplatform Beta, we also have announced that some Jetpack libraries add multi-platform support. That's a huge event, and also the KMM Bridge introduction is also the now one huge event, because I always check like all our questions in the documentation. We have this small widget like, was this page helpful? Of course, we have a lot of events, and this question, how can I, okay, monorepo is great, we all love Hello World applications, but how can I like put this simple model to my iOS app without a need to set up all the all the complex, let's use the word complex, like Android JVM environment. Yeah, that's important now. So I just want to emphasize how important to have the answer for that question. And I have a question before we go through.
Oh, I want to say one thing before I forget. The other thing that's important, and I hope we can help the ecosystem and JetBrains, SPM support. Like the speed with which Swift Package Manager has really like integrated with the iOS community, like being able to use SPM and Kotlin and do SPM local development. That's one of the things we added very rudimentary support for Cambridge to do that. But part of the design is like you can publish this SDK, but then if you're an iOS dev and you're like, I really want to build locally or debug, you basically flip a switch, and then you can, as long as you install the Kotlin tooling, you can test the same library and build it locally. SPM is rather difficult, and it's a long story, but it's critical that we get at least some support, and hopefully, like we can help the JetBrains team like do that too, because it's like it's going to be critical for adoption, I think. Anyway, go on with your question. Just want to say SPM important.
I can't argue with that. The question, we can discuss it also at the end of our webinar. Now I will explain why. So it's a little bit like in parallel with our like today discussion. But it's like it's the first question when we speak about adopting Kotlin platform for iOS. So now you started to show us, and you will show more how to put it together. But before that, usually all the developers who just started learning Kotlin Multiplatform, they ask like how to create the shared module before connecting it with iOS, but after answering what I will share first, for example, analytics. Okay, we already have this code implemented in Android, and it's a good question, like how to start making it multi-platform. It's also not a short question, again, like what is better, KMM or Flutter. So we can like put it in our stack and answer it, but
yeah, I'm gonna. I think I'm gonna address at least some of it in the next section, so that might help.
Cool.
And we can raise it after.
So it was a spoiler. Okay. I think again we have most of our questions. They are regarding like iOS API. So I think let's go through them and make a big Q&A session after Russell, after your part of the demo.
Alrighty. So let's throw my slides back up. So yeah, I'll talk a little bit about kind of the what the Kotlin Multiplatform and Kotlin Multiplatform Mobile library ecosystem looks like. And yeah, in the context of you're an Android developer, or you have an Android app and you want to get some code from there running on iOS. So the kind of rough schematic structure of a KMM app is a little bit like this, where you have this Venn diagram of there's an Android app, there's an iOS app, there's some overlap between them that is your shared code. And if you're starting from native Android, you're just kind of all in this left side. You can see my mouse here, but yeah, you're kind of all on the left side here. And your goal is to get as much as you can into the middle orange bit. So you're used to writing Android code. You want common code, which is this kind of subset of Kotlin that runs on all platforms. To be able to do that, you might also need to write some iOS specific bits, which is like whatever Android specific stuff you couldn't move into common, you'll need some analog for on the iOS side. So sometimes you're writing a bunch of that yourself. Sometimes you're making use of libraries that are doing that for you. But what matters to you in terms of kind of writing your app is what are the APIs that you can talk to from your common code. So before I get into kind of like specific dependencies and what things you might want to use, a couple notes on kind of the idea of converting your existing code versus wrapping it. So the first thing that you might think of if you're trying to write shared Kotlin code is take what you already have, convert whatever platform specific APIs you're using to platform agnostic ones, and then you can share it all. But something we've seen some teams do is instead of doing that kind of like bottom up sort of approach of changing what things you're calling into, take a more top down approach where you say, I have an existing HTTP client maybe on Android and on iOS. I'm going to write some shared interface around that. And then I can write common code that kind of talks to that existing code. And then you can kind of share that higher level logic. So you need to kind of find the right layer to set that boundary if you're going to do that. But it can be a nice way to kind of write shared business logic in a way that doesn't throw away whatever investment you've already made in your platform specific configurations. And I'll call out, there was a talk at the last Kotlin Conf in 2019 from Ben Asher and Alex Strong, where they mentioned this idea of like, you don't necessarily need to convert all your things to use the multi-platform dependencies, because you could just wrap your own interfaces around them instead. On the other hand, one thing that you do see sometimes is you have an existing Android app, and now you want to get whatever you can running on iOS and kickstart that. And at that point, like if you only have one side that you'd be able to wrap, that it's not as useful of a scenario. It might be more attractive to do more of a kind of port or conversion. So with that preface, I'll talk a little bit about kind of some of the KMM libraries that are out there. And yeah, I'll say one more time, like if you're kind of porting your Android code to Kotlin Multiplatform, you're going to need to change what APIs you talk to when you're talking to Android specific things. And if you're like a very kind of clean architecture style kind of app, like maybe you're already ready for this because you've already isolated all of your dependencies to like some weird little edge bit. But in practice, I don't often see like that's the code that everyone kind of aspires to write, but no one ever actually like gets to. So it's much more often in my experience that you see kind of the Android specific bits are kind of litter all the way through everything, and you have to kind of figure out what bits you can change. And I'll also say, so I'm going to kind of walk through a bunch of different dependencies that we see a lot of people use. We don't see everybody using all of these. So don't necessarily take this as like, this is the one recipe for everything you should do. These are kind of some of the things that we've worked with that have worked well for us. But every team will kind of vary in what their needs are and kind of what APIs they want to work with. And the last point I'll make is there's in the Android world in the last couple of years, there's been this kind of this movement around kind of modern Android development and kind of modernizing all of the dependencies that you're talking to, and kind of the more up to date you are with that kind of thing, I tend to find like the easier it is to do some of this migration. So like if you still have a bunch of Java code in your app, for example, you're not going to get to KMP very quickly. But like there tends to be decent interop for things that are kind of more actively used in the community these days. So I'll start with hopefully one of the kind of less likely ones that you might need. So a lot of native Android is moving in the direction of coroutines and flow already anyway. If you haven't yet, you probably would want to if you want to get any of that logic to run on iOS as well. So you'll want to take your flowables, take your live data, and move those over to flows. Sorry, oh yeah,
I have a question for this section. I was waiting for it, and I knew that the time I will have this time. So Roger is asking, 1 second, is it planned? Of course, I'll try to cover it, but I think the question is wider, and we can say what you can do if it's not planned. Okay, so is it planned to make it easier to consume flows on the iOS side rather than having to write your own wrapper? I can cover the first part about planned. So like currently, when we speak about interoperability, it's only about language interoperability. And as Flow is like a library concept, we don't, at least now, we don't have plans to cover it like in out-of-the-box support. But manually writing your own wrapper is not the only way to handle that. And here, Russell, I think you can give a more detailed answer.
Sure. Yeah, and I mean, I'll say I've just definitely done my share of manually wrapping, and I think that like it's often not as bad as it looks at first, because there's a lot of it that you can kind of that you can either try to offload to some code gen or can kind of like get some helper classes in place once that do 90% of the work. But yeah, there's also third-party solutions out there that will automate some of this for you. So one of these we've played with a little bit and recommended to some people is KMP native coroutines. It's library by Rick Leafus, I think is how you pronounce his name. I'm not 100% sure about that, but it's a compiler plugin that will like look at your Flow APIs and generate some of that wrapper code under the hood so that you don't need to write it yourself. I expect over time we'll see kind of more stuff show up from the community, especially as like compile plugin APIs start to stabilize, which is still I think a couple Kotlin versions away, but I think we'll start to see people play in that space more and more.
Yeah, I would tend to agree. I throw in like it's not too hard to write yourself, but like the automated part gets a little difficult because you have to do a lot of casting, and so like again, like we're not quite public with what we're doing yet, but we're doing some really weird stuff internally where we're generating some Swift and then compiling it back into the framework and perhaps making an amalgam API surface. But I'm not sure if we're going to dive into the reactive side of that. So definitely KMP native coroutines is something good to look at. But anyway, sorry. Continue.
Sure. Yeah. Does that cover enough? Or was there more?
Yeah, I think yes, we can move.
Yeah. The one other kind of little note I was going to throw out here is if you are migrating from RX to Flow, the Flow library has some really nice kind of helper APIs for you, where if you it has these like deprecated operators where if you start to write the RX Java thing instead of the Flow thing, it'll give you a deprecated kind of auto update to correct it, which is really convenient for migrating. So take a look at that if you're doing that. So for JSON serialization, the kind of main thing most people are using is JetBrains kind of first-party thing, Kotlin serialization. So if you're used to writing things with JSON or Moshi, Kotlin X is kind of the way to go, to the kind of close replacement for that. The big thing that changes there that you have to watch out for is a lot of people make use of reflective APIs in those JVM libraries, and you can do that even on the JVM side of Kotlin serialization. It has some reflection enabled stuff, but if you want it to work in KMP, you have to kind of go the full generated serializer route, which means you're passing this serializer argument when you're encoding things, which tells essentially what class is being serialized and the information about that it needs. And that can be something that might be something you handwrite, or it might be something that that is generated by the compiler plugin.
And also, I'm not sure if it's a good addition, but Kotlin serialization doesn't support XML, but I think it's a trigger to migrate from XML to some other format. But yeah, I needed to say that.
Yeah, no, it's good. I when I first made the slide, I titled it serialization, and then I added JSON because I didn't want to answer that question. There's also teams that use other kind of binary formats that do like protobuf stuff and things like that.
Sometimes they will learn it, so it's better to build their right expectations now.
Yeah. Yeah, well, and that's why I say like you'll often be happier if your code base is already in like a reasonably up to date place. Like if you're in the middle of migrating things off of XML to JSON, then that will, like, adding this on top of it will also make that hard. So for as an HTTP client, a lot of people are using Ktor, which again is JetBrains' kind of first party solution. It's nice because it has this very like native Kotlin API. It's all kind of DSL based. So you can go from the kind of Java style builders that you're used to from things like Retrofit or OKHTTP to these kind of Kotlin style builders in Ktor.
I have a short question regarding Ktor. It looks like you and the audience, you're prepared your slides as we have the questions directly related to your slides. Yeah, but okay. So here is the question. What is the recommended way of sharing network code with Ktor, for example, where I want to use some URL session configurations such as timeouts, iOS specific settings, blah, blah, blah?
Yeah, so on this Ktor client on the right here, the way that I have it written out here, which is what I usually do when I'm doing Ktor things. There's this engine argument, and that piece is platform specific. So there's a iOS engine that lets you kind of plug into some of those as URL session APIs if you need to customize that. There's multiple things you can do on Android. So you could, like the default Android thing is to use NS URL connection, but there's also an OKHTTP based one. If you want to maybe take your existing OKHTTP client and use that inside of Ktor.
Yeah, so generally, like all the agents, they need their specific configuration. And if you take like any sample, any open source project with Ktor, you can find the example how to configure it, configure platform-specific settings.
And this is a pattern that you'll see with a lot of multi-platform libraries. Is there's like a shared code piece of it, and then you inject some platform-specific bits that are kind of the engine running it underneath.
I think this is a good point to bring up the idea of like, do interfaces or expect actual? And you'll see a lot of this where it's like, where does that get configured? Oh, it gets passed in. That's because the configuration happens somewhere further up the chain, and it's sort of injected in. Expect actual is like a powerful feature, but I think it's the first thing every new person sees. So like, oh, you got to do this everywhere, and then you spend the first few months doing that, and then the next few months yanking it all out. So it's a much longer topic, but yeah,
another webinar, after KML versus Flutter.
Injection in interfaces is good. That you don't have to default everything to expect actual right away. You kind of get a sense for where it's good and where it becomes restricted. So.
Yeah, I forgot to put that slide in here because it's just like one of those things that I almost assume now is I like the first thing I tend to reach for is doing like a dependency injection kind of thing and passing in an interface implementation. But it can be nice to have an expect declaration when if there's a reason you don't want to do all that wiring, or if you have like a top level thing that you want to be a default.
Yeah. So the summary I tell people is like, interfaces unless you can't, and then expect is great for a default implementation function of a particular thing, especially in libraries. Once you get into library work, it's like, yeah, like Kermit, we have the platform default, and it's the expect function, and each platform just passes in the default logger. And then if you want to get a little more specific, then you get into configuration. So
yeah, it also can come up in libraries when you're, I'm just going to rabbit hole on this too much now, but yeah, it also go to libraries if you're just kind of like way down the stack somewhere. Like there's a spot in multi-platform settings where I just need to do something different in 32-bit versus 64-bit on iOS, and it's like way too far down to pass something in that the user won't ever see anyway. So expect is really nice there. But yeah, back to libraries and things.
Let's check if we have questions for your next slide.
Sure.
I'm wondering. Will we match or not?
Yeah. So database-wise, yeah, a lot of Android developers these days are using Room, which is nice, but does not work on iOS. So the thing we most often use for database stuff is SQLite. Realm is also out there as an option if you like kind of more of the ORM style. The way that SQLite works is it uses SQL statements as its source of truth rather than the kind of classes with annotations the way that Room does. So it sort of inverts the way that the code gen happens. Where like in Room, you're saying I have this entity class that I want to kind of turn into SQL. In SQLite, we're saying I have this table that I want to generate a class for, and then it will generate this like database class, this queries class, and then you can pass in, this is the platform specific driver that will be an Android thing or an iOS thing. The iOS one Kevin wrote most of.
The driver. I would, and yes, we're very close with our friends over at Square, so you should definitely use SQLite. However, if you want Room, again, the Jetpack team just launched a couple of libraries. And I would say let them know how much you love them and how much you want them to continue doing that, and possibly consider adding room. And they're listening, so make some noise.
Yeah. I didn't list much of that in these slides because they're all in kind of like very early pre-release state. But that's definitely a place that would be like the version of this talk that I give in like 6 months or a year might have some interesting Jetpack things on it if they get enough positive feedback that people want that.
We don't have any database questions right now, but we have our webinar planned from Realm team, by the way, and they will show you like step to step how to share your database layer. For SQL Delights, we have quite enough samples on GitHub. For Realm, not so much yet, but yeah, the webinar is planned, so please go and register for it and not miss it.
Nice. So that, I keep clicking the wrong thing. Yeah, that hits a lot of the major things. I'm going to throw key value store APIs in just because I'm the one who wrote and maintains multi-platform settings. But if you're used to storing stuff in shared preferences on Android, or if you're using Data Store and want to share that with some iOS logic, multi-platform settings has a class that essentially kind of wraps around all of those key value APIs. And then one more kind of like self shout out because we at TouchLab maintain this Kermit logging library that has a fairly similar API to what you might be used to if you're using Timber or just kind of like raw log calls on Android. There's also there's a bunch of other things out there because one of the first things that a lot of people kind of reach for when they're thinking about like trying out multi-platform library development happens to be logging libraries. It's at first it feels like an easy kind of thing to do. There's a lot of kind of subtle complexity once you kind of go deeper on them. Everybody wants different defaults for how they work. Yeah, Kermit's an option. There's others out there if you want some common logging.
I want to make a short step back to preferences, and
sure.
we have a question. Is there a library for encrypted shared preferences? As far as I remember multi-platform settings support encryption. Yeah.
So on some platforms, so there's like it'll work for mobile stuff. So there's a keychain implementation that you can use on iOS. And on Android, you can pass it essentially any shared preferences object that you want. So if you're using encrypted shared preferences, that inputs the same interface, and you can get encryption that way. And yeah, I'm more than happy to answer questions about that if that either on Slack or Twitter or later on here. Okay, so yeah. Just to stop myself from continuing to go on about every possible category of library, like there's like multiple solutions that are out there in the community for a bunch of other categories too, from dependency management. I'm careful not to say dependency injection because I don't want to accidentally start a holy war, but dependency management. There's kind of ways to there's not a mocking library that works the way that something like Makito or Mach-K does on the JVM, but there's a bunch of people out there now that are playing with just mocking interfaces, if that's something that's useful for you, and then a bunch of people doing different flavors of architecture libraries. So depending on kind of what your needs are, you often will be able to kind of find something that you might be able to migrate to that you can use.
Let's quickly, I suggest quickly go through the rest of categories. We have some questions.
Sure. Yeah, I should have thrown a question slide in here and I didn't.
Yeah, so the first one was about protocol buff, as far as I remember. Does protocol buffers work on both platforms? And we have a question before that.
Yeah, so the multi-platform protobuf stuff that I'm aware of is Square has their Wire library that has some multi-platform functionality. I believe I haven't actually used it, so I can't kind of speak to it in detail. but they both can let you they can let you kind of generate native code on both platforms, kind of from the same protobuf, the same protobuf definitions. But I think they also can generate KMP code. I don't know on the like first party protobuf stuff, but I don't think any of that is multi-platform.
I thought there was some gRPC support, but again, yeah, we haven't done a ton with it internally. I'm sure that I've seen that there's some gRPC support somewhere, and then of course there's Kotlin serialization, but it's kind of a different flavor of protocol buffers in a route. But like I want to say I'm almost certain the answer is yes, but we'd have to get back to you.
Next one, what about working with files, saving data on both devices like media files?
Yeah, that's the slide I should have put in here and didn't. So Square has the OKIO library, which is their kind of IO replacement for Java IO, which is now fully multi-platform, and that also includes some file system APIs. So you can write to the file system from there. I don't know that it has any like media specific support, but it is kind of well built for stream IO kind of scenarios.
I would throw out to you here too. This is a good point where, this is where Kotlin really shines. If you want to do something specific, like with files, so you want to say, I want to put this thing here, or I want to find a reference to this thing. Like it's, once you kind of understand how to write the shared code, it's relatively easy to just say, all right, I'm going to write a function that gets implemented somehow on one of these platforms. And then you just pass in that implementation, and rather than having to find a library that kind of handles all the stuff. So definitely look at OKIO if you want to do generalized file operations. If you need to do something very specific, it's really straightforward to just say, all right, what's the abstract interface look like? And then you just, quite literally, we pass in like Swift lambdas that are just like, all right, just do that thing. Or an interface implementation. It's actually really straightforward to do that stuff. So,
or maybe it's a good idea to write and publish your own library. By the way, like multi-platform ecosystem, like it's a good way to shine.
Yeah. I mean, actually, yeah. Oh, sorry, go on, Russell.
One of the things you might find kind of looking at the ecosystem today is there's a little less true now than it was a year or two ago, but a lot of the stuff that's out there is relatively low level still. Because that's kind of where people start, just kind of building things from the bottom. So like you'll find more something like OKIO being something that's like working abstractly with streams and having some file APIs, but not like maybe there's something else somewhere that someone will build on the road that's kind of more media specific and that's what you're looking for. Right now, you're probably building more of that abstraction yourself in your common code.
Okay, it looks like this library question is another topic for our webinar backlog, so I would suggest to stop here. But again, if we have time at the end, we can come back to this question. It looks like it's important one, of course. Again, if you want to migrate your code, I think the possibility that it's all like in pure Kotlin without dependencies, it's quite low. So you will need to find, you have to find replacements. Yeah. So, but okay, let's go further.
Sure. Yeah. I'll just say real quickly. Apollo is a good call out since you threw the message up. We've used that with at least one client, maybe one more, and it worked pretty nicely. So yeah, a couple quick notes on kind of developer tools. So ecosystem is not just like what dependencies can you talk to. It's also like what is it like to work with this stuff and kind of maintain code in this environment. And so a kind of big thing that comes up there is how do you debug things in your native code or your Kotlin native code. And so one of the kind of first pieces of KMM when like KMM was announced as a thing was this Android Studio plugin that gives you debugging support from Android Studio. TouchLab has also published this debugging plugin for Xcode. So kind of from whichever environment you're in, if you're on the Android side, kind of trying out iOS and you debug kind of the native code right from there, or if you're an iOS person who's kind of pulling in Kotlin for the first time, you have options for being able to set breakpoints, being able to kind of see some of what's going on. They run on essentially the same LDB logic internally. So like they're doing roughly the same things. They're just kind of plugged into to different IDEs. But the like if you're an Android person kind of trying to get your iOS team on board with this stuff, things like the Kotlin plugin can be nice. And that's an important part of this whole story is not just getting the code to run, but also kind of getting the teams all working together. And the last bit of tooling I mentioned is we have this Crash iOS library that TouchLab puts out that essentially helps symbolicate your crash reports that are coming from Kotlin, so that kind of by default you can you sort of lose the trace at the language boundary. So it helps kind of it helps you be able to see kind of from a crash report on the iOS side where in Kotlin it was coming from, which can be really helpful as you're introducing this stuff more and need to see what's going wrong.
Yeah, I want to throw out there that there is some. Yeah, we had it's a long story, but the short version is Rick again showing up in this conversation. It did some good work to help augment this. So we're kind of merging, like Rick's like he's got a library to help crash reporting, and then we're merging these things. But yeah, it's an interesting time. Although we've been so busy with other stuff, we've been sitting on like a PR for like 2 months. So hopefully in the next few weeks we're gonna get that sorted out. But anyway.
Yeah, that's one of the things on my to-do list for once we're done with this.
It's been a lot going on in the last couple of months. But
yes. So yeah, this is the memory management slide that I just threw in to say that it's not a thing you need to worry about that much anymore. So if you looked at the stuff in the past and were scared off by the fact that you had to kind of deal with this much stricter memory model on the iOS side than you're used to on the JVM side, now you can use the new memory model. It's enabled by default in 1.7.20. And so now you can kind of largely use the same concurrent programming patterns between the JVM and the Kotlin native side, which is nice and convenient. And thanks very much to the Kotlin team. And that's not to say, by the way, that you should still use all of the kind of concurrency primitives that you're used to when you're doing concurrent code, like atomics and locks and mutadixes and all that stuff. It's not like that problem is all like magically solved for you, but you solve things in the same way on Android and iOS, which is much more convenient for doing shared code. Does Kevin want to talk about memory management more?
No.
Thanks.
No. No, if you go it's like I made a career trying to explain the old memory model. So if nothing else, I've learned quite a bit about concurrency, but you don't have to worry about it now. So we're good.
Yeah, and this was where I had planned to stop for questions if there's any more on any of that last bits.
We have some, but I'm not sure what's the best place, what's the best time to answer it. Russell, Kevin, tell me, because we have some group of questions regarding iOS API, for example.
Okay, yeah. So I'm going to dive into some of that next.
Okay.
On kind of.
Then let's go. Let's show us the code.
Yeah. But yeah, if there's anything else, but I can do more. So yeah, some thoughts on just like what does it look like writing some of this code, some of the kind of architecture and design thinking to do, and the kind of big concept that I try to think about a lot is just like what does the shared code boundary look like? Like what's the interface of kind of what you're passing from Kotlin to Swift, which is really from Kotlin through Objective-C into Swift, which creates a share of complications. And it's one of those kind of classic it depends questions where what you're going to want to do is will depend somewhat on like how your code base is structured, what your needs are. But what you often need is like a weird sort of adaptive layer where, so like these are like Legos that connect to weird gears and things like that. You need some sort of layer within your app that one side of it talks nicely to Kotlin and the other side of it talks nicely to Swift. And it might do some kind of, funckiness in the middle. And you hope to kind of keep the size of that as small as possible. But you should go in with the expectation that you'll need to do some translating so that you both have a nice API on the Kotlin side, but also are exposing something nice to the native iOS developers who are consuming it from Swift. And this is like, if you're in that kind of more greenfield kind of scenario where most of your app is shared, it's not as important a concern, but it still does come up where you want to get things like your flows into a form that's easier to consume from something like Swift UI. So if you're in a greenfield kind of scenario, it usually like that boundary is usually somewhere in your view model layer. So you can, if your screens on both platforms are doing really exactly the same thing, you can often kind of use your shared view model directly in Android. You might do like an expect actual to give it kind of a base Android X view model base class if that's something that you're using. On the iOS side, you want to do some kind of translating so that on iOS, you can't consume flow very easily. For two reasons. One is Flow's interface, and Kotlin's generics only make it through to Swift on classes and not interfaces. And two, because it's most Flow APIs are suspend based, and Swift just doesn't really have the same concept of that. And there's some experimental support kind of starting for mixing async await things and suspend functions. But on the Flow side, it's this kind of like, it gets exponentially more complicated because like each of your operators is then another suspend thing. And it also gets complicated because the language level support only knows about the kind of language level of coroutines and not the library level that lives in Kotlin X, which means you lose things like cancellation isn't easy to do from the kind of default stuff. So I often end up with some form of passing callbacks and wrapping them. On the, like, if you're in an established app, like you're doing something sort of similar, it's just you're starting from a more complicated place. And so it's hard to kind of have a kind of cookie cutter step-by-step of like, how do I pull out a nice sort of thing? It's really something you have to kind of use a lot of the same skills that you might use if you're refactoring a legacy app. So like find some place in here where like, oh, we're contracting this thing inline. Maybe we can move this class to being something in my shared code and kind of pass it in rather than constructing it inline, and then that becomes some of my shared logic. So you end up maybe with something that looks kind of like this. And this is just kind of like a dumb toy kind of example, so it may not be that representative of what it would actually look like for you. But the general idea is finding a piece of the logic in both of your apps that is doing enough of the same thing that you can kind of peel it out as a shared thing and then pass the results of that to each of the platforms. And just because I was mentioning the comparison to refactoring, one of my kind of favorite books on refactoring tricks is this Working Factory with Legacy Code. It's in the back of my mind often when I'm doing KMP refactors of like, how can I kind of peel out a nice interface of shared code? And there's a lot of kind of good tips in there. So he didn't pay me or anything to say that, but it's a book I really like. So yeah, summarizing some of those tips really quickly, and I think I'm just going to repeat myself. Yeah, so don't be afraid to add that translation layer. Yeah, like, so I often don't like to change the shared code that much just to accommodate Swift, but one of the places where I often will is kind of putting classes instead of interfaces at the language boundary. And yeah, make sure you're having a conversation with the Swift and iOS developers on your team so that you know you're actually giving them what they're looking for and that you're actually kind of working together on it. So I'll give a kind of quick
one thing I want to, the Swift, that the interfaces versus classes is not because of Swift, it's because Objective-C doesn't allow generics on interfaces. So they get stripped out. Just wanted to throw that out there so you understood why.
Yeah. No, sorry about that. So just as a kind of example of what some of this stuff might kind of look like. So everyone tries to make their apps like all like spiffy and fast and whatever, performant. So I want to differentiate myself, and I'm going to write this slow calculator app that delays every time it tries to make a calculation. So I'm going to write like this is kind of my shared code logic, and I'm going to kind of play around with how that exposes to Swift. So if I move over to Xcode, if I sorry, my laptop moves slowly every time I change screens. So I can instantiate that slow calculator on the Swift side. I can call into that add method, which I should highlight. Like, so there's a spend method in here, and there's a flow method in here, just so we can kind of play with what those both look like. So you can call into that suspend method, and Kotlin generates this callback version of it that gets exposed to Swift. So it will asynchronously pass either a result or error. You can check if there's an error or spit out the result. And if I run it, I actually already ran it, so you can see that output. But you don't get cancellation, and you might want that. So like what if I kind of made these all longer? The dumb thing that my API is doing is delaying for the total here before it returns. So if I run it with bigger numbers, instead of kind of popping the result instantaneously, it's going to take a couple minutes, or it's going to take a couple seconds. What if I had then like navigated away from the screen or something, and I wanted to cancel that call? This is returning. This is just returning void. So I don't get a chance to. I don't get any way to cancel it. But so I'll give that a couple seconds, and it'll finally return. Yeah. But what I could do is kind of add an adapter around it. So I have this kind of wrapper class that instantiates its own kind of common calculator, and adds a coroutine scope for things to run in, and then can kind of launch a job and return this. This canceller is just a thing that knows how to call job.cancel, so that we don't expose the job directly to our Swift API. So if we do that, we can this moment to load. So if we build kind of the iOS version, then we'll we return a thing that can cancel, and then we can call cancel on it, and we'll see it. We'll see the cancellation error come out instead of waiting for the result. If we didn't cancel it, we'd do the same thing the other one was doing. So writing that sort of wrapper can be a nice way to kind of plug into things in a more natural way, I guess. And you could, instead of just kind of passing these callbacks directly, you can plug that into whatever reactive API you might want to use on the iOS side. So you can convert these callbacks now to Combine or Async Stream or RX Swift if you're using that. Which I'm not going to kind of show all of those here because I just want to kind of like show a quick minimal example. But the idea is like you even if kind of the thing that's coming out by default isn't exactly how you want it to look, you have room to write some extra support around it to get the API service that you want.
I think that's a great time to answer one of the questions. It's also quite popular.
Sure.
1 second. Yeah. So do you know their Swift API bridging with Kotlin Multiplatform Mobile is on roadmap? I read it's pushed back, so we are stuck with Objective-C API. So the question about direct interoperability with Swift, and the reason I wanted to jump in with this question, because like Russell, it was the great answer for it. First, if you check the Kotlin roadmap, you can see the roadmap ticket related to direct interop, and it was postponed due to lack of resources. So like in future releases, we don't plan it, but here is the Russell's answer comes. So first we have some plans on improving interoperability with Objective-C. For example, there was a question like, can I use nullability in my Kotlin code? And well, Objective-C also supports nullability, not in its first versions, but in the latest one. So some issues with interop will be improved even without having this direct interoperability. That's from Kotlin team. And like from the community, you can find like a lot of good examples, like how to improve your Swift API, like manually, just Russell showed us, or using some existing tools which will generate all this like adapters and wrappers for you.
Yeah, and actually, like the stuff I'm doing right now, I was just handwriting, but yeah, there's things that can generate stuff like this. So I've been talking for a while, so I want to pass back to Kevin so we can show his demo at some point. But I'm also in a good spot right now if people have kind of questions about like API translation particulars. I can kind of bounce back and forth and show what things look like.
I did want to throw out one thing, or a couple things. Swift is pushed back, but I think, I assume eventually it'll happen. There are some issues to point out there, though. I gave a talk about this at DRICON Berlin, I don't know, a couple months ago. It was all about this layer and like things you should do and shouldn't do, and how to produce the best outcome on the iOS side from the Kotlin side. And it's actually one of those things that as you get more into it, you really have to learn. Well, and I don't know when or what we're putting out, but we're internally building this sort of our next top secret thing, which actually does try to improve these layers. Like, even with direct Swift interop, like a sealed class doesn't exist in Swift. Like you have to, there are some sort of higher level decisions you have to do to retain the expressiveness across that sort of chasm. So, but it's one of those things where, Objective-C isn't perfect, but you kind of have to like keep the big picture in mind, which is like you also only have to write one set of code for this particular module, and then we're just trying to make the way that you talk to these two things as good as we can in the current context, and everything's improving over time, So,
the other point I'd make along those lines is you don't necessarily need direct Swift interop to improve the interface that gets exported to Swift.
Oh, right.
And there's like Kotlin team's working on that. Like we're playing with some stuff. There's other third-party people playing with stuff.
Yeah, like part of this Berlin talk was that we used to recommend having like an API layer specific just to the iOS coming out of Kotlin, and that wound up, you could craft it the way you wanted to look, but there was a lot of sort of code duplication. And now with better code generation and better configuration with annotations and stuff and compiler plugins, like you really can kind of get rid of that. Just there's things you have to be aware of. Like again, a sealed class is not going to look great. You should pick other options unless we have this thing we're generating that's going to improve it. Default parameters aren't there. You kind of write extension functions, but all that stuff's going to eventually be like auto-generated, and it improves over time. But anyway, we are it's like we want to get back to our non-linear storytelling, and I'll go back to my demo.
Yeah.
I don't want to run out of time here. We're an hour and a half in.
Yeah.
All right. And then we can get back to questions until we run out of time. Let me know if I'm sharing And
oh yeah, I mean, or,
yeah,
You are.
I'm sharing.
Yeah.
All right. Well, if I'm not non-linear storytelling, if you recall last time on Kevin's demo, I created this new repo from our our Cambridge Kickstart, and then I changed the group name and I started the build action. So as you can see, that build action has completed. So what we're going to do is say quickly just show you that what that did, which inside of our private GitHub repo, we've created one release, which is 010, and we've got some packages. And just really briefly, we've got there's my big face there, the Android AARs, which you can use if you want to, again, if you want to have a third repo for your share code, you can pull them into your Android app. And then we've also got this special Maven target, which is called Cambridge, and this actually inside it has the XC framework as a zip, and depending on your configuration, you can pull that into with SPM or CocoaPod. So we're going to show you SPM really briefly, and GitHub is managing the auth here, so that's how you can get your team. You can get the auth managed automatically, so it's private and all that kind of works together. I do want to briefly mention that this is using Maven publishing, standard Maven publishing, to push out these XC framework zips, which opens up a lot of options for alternative backends. You would highlight that we have documentation on how to do this with JetBrains Space, because there's packages in JetBrains Space, so you can publish there too. And there's Artifactory, whatever else you might use for a standard Maven publishing, as long as there is a standard way to consume that artifact through authentication. We go through the docs. I won't show you that part here, but the one thing you have to add here is in a netrc file, you have to add your what do you call it? Your authentication for your GitHub packages, right? So it's one thing you have to do. It's all in the tutorial. It's not so bad. So anyway, what we're going to do here is consume this artifact with SPM. So we're going to make a very basic rules SPM Swift UI, nothing special here. And then we go through, save this into a folder. Okay, I'm just streaming. Things take a little longer sometimes. All right, so we have a very basic Swift UI thing. All this is going to do is print hello world. I'm going to switch this to that. And what we want to do is access our, what do you call it? The thing we just built. That's what we call it. So I'm going to go in here just to get this URL. This is the URL for the repo. We go into Xcode and say add packages. You have to log in with GitHub. That's pretty straightforward. I have way too many GitHub orgs and repos, so rather than searching through them manually, I just put in the URL here. That gets that. I would make sure to pick up to the next major release version. You'll notice it autofills 010 because that's where we're at. And we're going to add the package. Hopefully this all goes well. I'm on a hotel Wi-Fi and streaming, so cross your fingers. This is why live code tends to be whatever. So anyway,
let's discuss Flutter versus Kotlin Multiplatform Mobile questions.
Yeah, let me, while this is happening, I'll try to walk through some of the other things. So hold on. So we have again the Android ARs. That framework we built is an umbrella framework that kind of puts together multiple modules that people were asking about. That we can get into it later. Anyway,
I wonder if we want to talk about what is in. Oh no, it's done. Okay.
Yeah, no, that's it. So that's in there. We're gonna do import all shared, and then I won't explain exactly what this is doing, but let's see if onto this file we have a startup call that gets our little SDK. We're gonna do this and say hello, which I don't have IntelliJ open right now, but I'd show you. But all this is doing is going to return a string that's coming from shared Kotlin. And then we can hit that and I don't know how long this is going to take to build because we're streaming while this is happening. So, but anyway, I mean, oh, build failed. Great. Oh, I know why build failed. We're going to live debug as fast as we possibly can. I forgot this one step. I've been doing a lot of different demos lately, so sometimes you miss a step or two.
Now we can see how to troubleshoot. So it's a good demo. It's a good. How we can call it the demo if we don't have failed builds.
Yeah, the part is that we can add it to our troubleshooting docs, right?
Yeah, else SQLite 3. This has been since I started doing this.
Could you explain, please, why you add this flag so we can?
Because our sample uses some SQLite,
okay.
And in order you have to link that. It's like I think Android developers are like, what's linking? You have to tell Xcode where to find the actual binary for that thing, and so then it's like, okay, I know where SQLite is. We're going to add better support to pass along those values in our dependency management. But right now, again, our SPM support is like, it's like, all right, it works, but you do have to do a little more manually. Anyway, hello from TouchLab. That sample worked.
Oh my God! Congratulations.
Yes.
To all of us, because we don't now.
But again,
don't need to open.
But again, like to highlight, it's like you go here, use the template, change the group, hit publish, and then you just pull it in. And that's as easy as it can be to get started. And from there, you do some more, just change the code, do some more stuff, and and you can easily integrate this stuff into production apps. So that's the demo. All right, we can stop sharing my screen.
I think we need to make a noise to send applause because this was the unique moment.
Yeah. I'm used to speaking in front. Like if you speak in a live crowd, people will make noise. When you're doing this virtual, it's like, I hope that was interesting. Yeah. All right, we done sharing?
I do see the comment count keep going up, but I'm not looking at that tab to see what's in it. But I know people are paying attention.
I sent some clips.
Cool.
Oh, we have more. Okay, thanks to all of you. Okay, we are not sharing. No,
okay.
Right now.
Yeah. No, we're good. All right. Yeah, I mean the other part to finish that demo, like if those Android ARs, you got to include them, and you got to do some auth, but like that's normal, like Gradle stuff. And again, this is why I'm like usually, as long as everyone's cool with it, just to have a KMM module in your Android project makes that all kind of easier to do it. And the publishing to with Cambridge is just as simple. So, do you want to do questions, or what do we want to do now?
Of course, we have more of them. Now I tried during our demo. I tried to group them and reference to our talk sections. Now let's just go through all of them. But again, I try to keep the topic. So let's start. Let's start with this one. When will the multi-module support happen? We also have some questions regarding multi-module duration. It's impossible to reference shared signatures when that class interface is generated at both binaries. Is there any workaround other than umbrella approach?
Well, so this I talk about fairly often. From starting from the end, is there any workaround besides umbrella? No, there's not. When I give my talks about this, I tried, rather than explaining the situation, I explain like why it's that way, right? And the reason why you have to do umbrella, the reason why these are binary incompatible is it's easier with a diagram, but just because you include, let's say, SQLite as a library or Ktor as a library into a module doesn't mean that the compiler includes the whole thing. The compiler is extremely conservative about what it's going to include. The reason is, if it includes the whole library, you're going to have a much bigger binary. And I kind of point people back to the beginning of Swift, where it's like when you first started using Swift, it was going to add a significant amount of binary to your deployed application package. And I would argue that Apple knew that over time, once it stabilized, they were going to ship that with the phone. I don't expect Apple to start shipping Kotlin runtime with the phone anytime soon. Like, ha ha ha. So the compiler has to be extremely conservative and strips everything off it possibly can. The problem being, if you have two separate modules, the compiler doesn't know when it's building them what's going to need to be there for both of them, right? So there are workarounds that are in progress from the JetBrains team. I have no idea about timelines, but like one of the issues with Umbrella is that the names all conflict. So you have this like name conflicting thing, and there's going to be separate namespaces even within the Umbrella modules. That I think is in progress, and hopefully is going to come at some point in the not too distant future. Having separate frameworks, the problem is you would need to compile them at the same time so that the compiler knew what to include and all that kind of stuff. So the Umbrella approach is one of those things where I just kind of tell people, like, you got to set up your CI to build different things for what you need, but assume that the Umbrella is here to stay for quite some time. So
yeah, like I imagine kind of the tooling support around it will get better over time. Like,
yeah,
databases.
And again, like talking like some of the bigger teams, like I said, some of them from like, well, like I'm like, wait, NDA, can't say that, but one of the big topics is as you're scaling, as you're adding a bunch more stuff, even with Umbrella, like although you can have one module, you do get the name collision. So the having namespaces is going to, I think, help with that dramatically. And there are PRs that let you control what names things have. So if you need to rename something, it's, you know, it's not done automatically. You'll be able to control it better. So.
Oh, okay, thanks. The next one directly relates to this amazing demo. And I believe you covered it a bit, but never too late to again repeat some important stuff. What about debugging in iOS side when multi-platform Kotlin multi-platform module is remote iOS dev, you fetch and debug it in Android Studio?
So from the what about debugging it with the remote came a module? It's interesting you asked that. Like, we had built this whole much more complex build like pipeline system that would essentially distribute debug frameworks that you could debug on with your Xcode without having to build them locally. We backed off of that just because, like, there's, you know, we might get back to it eventually. Like, there's sort of this magic you can do, but it's a lot more to figure out.
It had some limitations that we weren't
right.
Quite sure.
There's a lot more we'd have to do. We have to see if there's value in doing it, because essentially what's in the Cambridge thing is like, yeah, it's a remote now, but if you want to debug, just install the JVM and Kotlin locally, which is not terrible. Just do it, and then you can flip a switch, which you just tell Xcode to look at your local build rather than at the remote one, and you can then just debug. So that's what we recommend right now. If you're going to use in Android Studio, I mean, it's the same kind of thing. You're going to have to install Android Studio locally, and then that kind of gives you the whole JVM and toolchain anyway. But at that point, we're kind of looking at it like, if you were strictly an iOS developer, at the point you've installed Android Studio and you're debugging Kotlin, you're kind of getting into mobile dev range. So yeah, the remote debugging, that's where we're like, well, if you're at the point where you're installing all this stuff anyway, I'm not sure that you need that, but it is possible. It's just it's a lot more involved.
Okay, great. Another one, is it possible to publish a Swift package manager with an included Swift wrapper? Coming back to this question about wrappers. That is, have you tried a source plus binary Swift package manager?
Well, is it possible? Absolutely. Have we published the tooling that would allow you to do that? We have not. So that's a hated topic internally, because we've got some weird magic stuff that's just at the point where we're going to look for people to pilot it. If you are interested in that specifically, please reach out to Touch Lab, and one of the various ways that you can reach out to us, ping us in Slack, go to the website, you know, Twitter, whatever. We are going to be looking for people to pilot that soon. Essentially what we're doing is Swift generation and compiling directly back into the framework, so you have this sort of you know, amalgam API that's going to help stuff quite a bit. So again, this is part of the, like, in the next 6 months to a year, the situation is going to change rapidly and dramatically, and hopefully this is one of those things that will do that anyway. So possibly yes. Can you do it now? Different story.
Yeah, there's a clunky version of it you can do now where you just have kind of two separate things in your package file, and you see them as two separate imports from your app, and it feels a little clunky.
I would. I don't want to phrase it as clunky, but you can also there's like the Mocha folks. They're doing K-Swift. Like it's kind of like two packages, and it's but it is more complicated to deploy, and there are naming issues and it's all kinds of stuff. So just prepare for that. We're trying to like solve the root issue, but it is bigger than a breadbox kind of problem to solve.
Great. Okay. So short agenda for the last part of our webinar. Let's go through a couple of general questions and finish with one specific question regarding KMM bridge, and then say goodbye to everyone. Finish, but only for today. So the general one, I just noticed this thing. We want to migrating KMM Alpha to KMM Beta to support iOS. Is there a good way to get off of Alpha and onto Beta? I just can quickly answer here. So if you are using last Kotlin version, then you are already using KMM Beta, because for Beta the main technical change is that the new memory manager don't think about the memory model. Like the memory model, I think we need to stop using new, and that's how we will close all these discussions. So that means that you're using Beta, so you don't need to do any special migration to use Beta. We don't have any breaking changes in terms of multi-platform API or something. So congratulations, you're already using Beta, I hope, or you need to upgrade Kotlin version. And this popular group of questions, they always go together as a couple. First one, what's the impact on app size because of Kotlin Multiplatform Mobile on iOS? And the next one, I will use both of them. How is the performance when compared with native Swift? Binary size and performance, the great couple.
Binary size is much easier to answer. It's one of the notes I had in the section I don't think we're going to get to, but just especially for the Android folks out there, the size of your Xcode framework on your dev disk is not going to be the size of the binary on a device. You have to get prepared for just because I talked someone through this a couple days ago, it's 20 megs on your dev machine. That doesn't mean it's going to be 20 megs on a device. And it's not even just how big is it on a device. It is what is the impact of adding this framework to the overall size it's going to result on a device. And measuring that, especially in iOS, is a different thing than on Android. The gold standard is to push your app to the App Store Connect, see what it tells you it's going to be, and then add Kotlin and see what the difference is. The TLDR version is if you just do basic Kotlin with some strings and no libraries, you kind of pay this startup tax of about $500K, and after that it's kind of linear growth. If you take CampKit, which has SQL Delight and Ktor and all these other things, and a fair amount of logic, that's 1 to 1.5 megs, and after that the size growth is roughly linear as you're adding Swift classes, adding Kotlin classes the same. A couple of notes really quick. You want to limit your visibility, so anything you can make internal in your Kotlin code, you should do so, because anything that's exposed to the iOS side directly, as in it's in the header of your output, is going to add some binary as an Objective-C adapter. And it's also very easy to drag in dependencies that you don't need. If you reference one thing from coroutines in your public API, it's going to have a whole bunch of coroutines now has to get exposed to iOS. So there's techniques, there's multiple talks we've been about that. Go check those out. But TLDR, the size impact is not crazy. It is generally acceptable, certainly, and we can give you more details on that or how to measure that if you're really interested. And, performance.
Yeah.
Well, it kind of depends what you're measuring, and I just had this long talk about this yesterday. I was at the Google thing yesterday. It's I would say that, you know, what's performance to you? Like if you're like, I need, you know, game level, something comparable to C++, it's like, well, then you probably need C++. If you are doing data access, network access, database stuff, almost always you're gonna, the time it takes to do IO or networking is orders of magnitude compared to anything you're doing locally as far as performance. I would say that there's still places that Kotlin native should optimize, but there's also some stuff that's going to compare favorably. But bear in mind, especially not even native Swift, like a lot of people compare Kotlin native to the JVM, and the JVM's had multiple decades of optimizations going on behind it. So don't get too caught up with that, right? It's like how performant does it need to be for you is kind of the question I come back with.
One thing I wanted to mention here is that based on our users' feedback, those who migrated to memory manager, they noticed not only that their like developer experience was improved and routine simplified, but also surprisingly, they noticed some performance improvements. So I use surprisingly because like this performance question was not the main thing for the new memory manager, and we even for its some early versions, we were expect some downgrades because we were trying different approaches. But anyway, we got some great reports. So again, if you haven't tried it yet, please do so. And again, if you want to use Kotlin Multiplatform Mobile Beta, that means that you will use new memory manager. I just can't not use this opportunity to mention it again. Okay,
yeah, it was really fun watching the early previews of the memory manager, because like at first there were all these warnings about like, oh, there might be performance issues because we haven't optimized anything yet, and it quickly just all went away because it was actually working really well.
And as I promised, the specific question, good question to finish our discussion. Is there a migration design doc from a Kotlin Multiplatform Mobile monorepo to Kotlin Multiplatform Mobile using KMM Bridge?
So I would say that like that's not exactly the migration that we're envisioning KMM solving.
There you go the other way.
Yeah, it is like, oh, you're starting from a place where you have these two separate native repos and we're trying to kind of migrate to more shared code.
Yeah, I mean the name is sort of implies the like this is bridging this thing, and later you're going to have them in the same place maybe. Like, so it's the bridge is the first step.
Okay. Yeah, I think that's it for today. Again, Kevin Russell maybe has some like closing word, like do so and don't do this and don't do this.
Mine would be don't schedule your live video talk when you have to get to the airport immediately after. So wish me luck. But I would say, you know, there's a lot of detail and a lot of stuff you got to figure out, and like you're gonna run into issues, and like, but it's like anything else, you're gonna run into issues. Just like, you know, give it a shot. Like it's easy, and this is why we did the bridge thing. Is like it's so easy to just like spin up a thing, throw it into your app, see that the code works, change some stuff, and just see how it goes. And you know, maybe it's like this isn't for us or whatever. But I would say that once you get past those initial hurdles, there's more teams than you would think using this in production already, and that was before the beta announcement. So this is growing in popularity. And I saw someone ask me before, like, does beta mean you can use it in a large code base? I'm like, well, there's several companies out there that have already been using it in a large code base for years. So like the whole, is it production ready? It's like, well, that wouldn't compile because it's not a binary question, to put that in nerdy developer terms. Like production ready means, I don't know, is it good enough for your team? And I would say a lot of teams have been using it already. Beta means it's even more ready still, and then just give it a shot and see how it goes.
Great. So see you on our next webinar next week. Check the schedule in our blog post, and don't forget to subscribe to our channel, of course. And wish Kevin good luck. And let's say bye so he will able to get to the plane.
I'll be
Bye.
fine. It'll be all right.
Everyone, thanks.